For more good information on wiring diagrams, visit George Benshew's site. Here's the link, and you can find it at my website as well. Now we're looking at a new diagram here. This is for a headlight door module. It's for an 89 Pontiac Trans Am with a 5.7 engine. Now what do we mean by a headlight door module? These headlights, as you'll see, when you turn the headlight switch, they not only turn the bulbs on, but they actually have a motor that opens and closes the cover. So it's the diagram for the headlight door motor. Remember, you're going to learn more if you'll color code the diagram on your own before you view the video. That way, if you have questions, hopefully we'll make the answers. Now, I want you to make 2 copies of this diagram. The first copy is for the at-rest position, and the second copy is for when the circuit is activated. I'm going to illustrate both in the video. Now we have a headlight door motor, and we have 2 headlights, so we actually have 2 motors. Now there is not a motor for open and a separate motor for close. You have one motor that opens and closes, and the other one opens and closes. So this must be reverse polarity. So reverse polarity means some of the wires will actually be power and ground, just not at the same time. So let's see how this works. Okay, our 2 motors are at the bottom, and now we have a headlight door module. We actually have a relay in here as well, and then we have a light switch at the top. The light switch has 2 power supplies. One comes in over here, and the other one comes in. So there's actually 2 power feeds to the headlight switch. And we actually have 3 fusible links. They are hot at all times, and our ground comes from the bottom. We have 1 ground input for this circuit. Now let's talk about the links for just a minute. There's 3 of them, and if you notice, they're connected at the top by a dotted line. That dotted line means they're all connected at the very same point. Now the link on the left, if you notice at the very bottom it says headlights. That means this link powers the headlights. It has nothing to do with the door module. These 2 links feed the door module. Now how do we tell the difference? The 2 that go to the door module have a red wire, and the one goes to the headlights has a red with white wire. Now over on the right you see a dotted box. That means this is 1 fuse, but because it's dotted there means there's more here. So this fuse is inside the main fuse box. And we have some solid line boxes. Again, this switch is solid, so all the connections are here. And you have an outer solid box and you have an inner solid box. They're both control units, but they are connected inside, so that means there's circuitry connecting these 2. So first, let's color code the diagram at rest. We have 2 power feeds into the switch. One comes in, it's hot at all times, it travels down and stops at an open. The next one comes in, it is hot at all times, but it actually has a closed switch here. Remember, this is at rest, so this will remain red because there's power all the time. It comes down and puts a power input right in here to the headlight off input, and then it comes over, travels down through a closed switch, through the continuity in the motor, travels until it hits an open where it stops, continues until it hits an open where it stops, and then the same thing on this side. We have a fusible link over here that is hot at all times, so it is going to come down, and the first thing is going to put a power input into this module. Then it's going to come down and it's going to continue until it hits an open. And we have the second fusible link that does the same thing. Comes down, and notice it's got its own power input into the module. And then it comes down and stops at an open. So we have 2 powers, so evidently this module can tell if one or the other fusible links or one or the other headlights doesn't have power. And then of course we have the third fusible link that is for the headlights. Now remember, this is at rest. This circuit is drawn at rest. We haven't got the ground here yet. This is the power side. And almost everything has power, and it's at rest. If you look at all the connectors here, we're going to have a ground here. This is power. Almost everything has power. So here's our ground. It comes up, it travels, first off it goes around this relay so that it can send a ground input signal into the module. Then it continues on. It goes up here and sends a ground input for the headlight on input. And then it continues on here and it stops at an open. But then it continues here and goes to the headlights to give ground to the headlight circuit. Now also notice in here we have grounds. Now these are not direct grounds. This is the direct ground, body ground. But these are grounds from the module when it wants to give this circuit ground. It will actually turn these on. But right now these are open switches, so these grounds are just there, but they're not going anywhere yet. Now I want you to note, hot at all times means that if you were testing this system, there would be power at almost every test point with the key off. You would have ground here. All of these pins would have power. Power, ground, power, power. So almost everything has power with the key off. The headlights are off. The door motors are closed. And this is the full rest position. So how does this circuit work? Well, first we have to turn the light switch on. Notice that this is a double throw switch. We have 2 points, and the dotted line between them means that both switches are going to move at the same time. Now let's show this in steps. What I mean by that is, when we activate this switch and both of these move, we're going to activate the circuit, power and ground is going to move. But I'm going to show you one at a time so that we can keep it separate. The first thing that happens is when this switch, which was normally closed, becomes an open, then this power just stops right here. All the power that was traveling down here no longer has power. Second part of the switch, this was an open, but it's actually going to close now, and when it does, our circuit becomes switched power. We have power here going to the headlights. We have power coming down into the module, and notice now we have power at the headlight on input. So when the module sees power here, it knows that the headlights are on, or should be. Power comes down here. Now we're at the relay. Now the relay, is an electromagnet. It already had ground here, and now that we've got switched on power, this electromagnet can operate, and it's going to close these relay switches. Now if you notice, there's 4 relay switches here. This dotted line means that when this magnet energizes, all 4 are going to move at the same time. There's our 4 switches, and they're all in this position. Now on this diagram, it might be a little confusing. Normally when we talk about open or close, we're talking about a circuit. But in here, this door motor is going to open or close the doors. So what they're referring here to, even though this is a closed circuit, it is in this position when the motor is in the closing the motor. And when it wants to open the window motor, not the window motor, the headlight motor, it'll move to the open position. So when the electromagnet energizes, these switches move. Now if you notice, this one comes over here, it closes, but because it's connecting to power, this is going to be switched on power, and this one as well. But this one now, even though the electromagnet pulled it over, it's not connecting to anything. There's nothing on this side of the circuit here, so it's making a complete connection. Now, as this completes, we close this switch and we connect to regular power. We go to switched on power. That power is going to come down here and stop at the motor. Now we're going to have ground in a minute, but I'm doing this in steps. So this is the power side to the motors. So the motors are going to run now, and how do they do that? Because now the module sees the headlight on signal, so it closes these switches. So this switched on ground comes through here, it stops, because remember this is now an open switch because it's switched over here. But it is now a closed switch, so this ground can continue, hit the power at this motor, and this motor will run. And notice the headlight doors are going to open. And the same thing on this side. The module closes, it comes down through a closed switch, and the headlight motors open. So, how do the headlight doors close once they're opened? Okay, here's the same diagram we were looking at with the headlights on and the door motors open. Here's how they close. First thing is to turn the light switch off, and then everything is going to happen. Now if you look at this, we turn the headlight switch off. This switch, which was over here, now completes, and we have power on this side just like we did before. This opens. It was connected, we had switched on power. Now this isn't open, so now our ground continues through. At our headlight on position, we now have a ground, where when the headlights were on, this was a switched on, so that's the signal. Now we have power over here at the headlights off position, so the sensor input over here says, well, we've got power, the headlights should be off. Now if you notice here, our doors are going to close. What happened here is we now have power on the right side and ground on the left side. Because remember before, when this came down here, it stopped because that switch was open. It was going over here to the switched on power. But now since our relay turned off, this switch moves back, it connects with ground, and so now we have ground on this side of the motor instead of this side of the motor. I'm going to back that up and show it one more time and watch how it switches. I know that was kind of fast, so I'm going to do it one more time. So with our headlights on and the door motors open, we had switched on power on the left and ground on the right, and when we turn the switch off, the motors close, and now we have power on the right and ground on the left. So we've reversed polarity. So some of these wires will carry power or ground, just not at the same time. The motors reverse polarity and they actually run in the opposite direction. After they close, or the door motors close, the module then will stop the ground to the connection. There's still a ground here momentarily so that these motors can run in the opposite direction and close. But after they close, these switches open so the grounds can't travel, so we're now actually back to the very original diagram we started with at the at-rest position. So now you can see why I wanted you to have two copies, because if you were troubleshooting this system, one would be for testing at rest to show that you had power and ground everywhere it should be. But if it wasn't working right, then you'd have to be able to see it activated.